Hi everyone, welcome to Mr. Techpathy Tutorials. This is part 14 of Linux device drivers. In earlier sessions Linux device driver part 13, we discussed about allocating and freeing major and minor numbers. We discussed about the best way to allocate major numbers for a device. We also learned how to write a small code snippet to allocate device numbers for our skull character device. This session is an extension of previous session where we are going to learn further steps which we need to follow before writing a simple character device driver. In this session we are going to discuss following topics. Important data structures. Under this topic, we learn about file operations, file structure, inode number, and inode structure. Most of the fundamental device driver operations involve these three important kernel data structures. Before writing a device driver, it is very important to gain basic understanding of these three data structures. Let's start with file operations. From earlier sessions, we know how to allocate a device number for our device driver using register character region or allocate character region. Now we need to connect our device driver operations to these numbers. To establish this connection, we need file operation structure. This structure is defined in Linux header file fs.h. Each open file in Linux is associated with its own set of functions. These set of functions are included in a field called f_op, which points to file operation structures. In short, we call pointer to file operations as fops. Each field in this file operation structure must point to function in the driver that implements a specific operations or be left null for unsupported operations. This small diagram here will give you a clear picture on how the file and file operations are associated. If you consider this as an open file in Linux, which contains a field f_op that points to file operation structures, which again carries the function pointers to the functions which the driver supports. Let's list few file operations. As you can see, it's a structure which contains function pointers to various functions like open, release, llseek, read, write, and ioctl. For convenience, I have written function pointers to each functions in plain English here. If you really want to see how these function pointers are, you need to check the next slide. These are the function pointers which are under file operation structures. The first parameter is a pointer to owner of type struct module. This is a pointer to module that owns the structure. The rest are function pointers to a particular functions in the driver. I will leave it for you to pause this video now and read brief information provided under each entry. Now we know about file operations. We have been learning a topic and applying it to the Skull device driver. Remember, our main aim is to code small snippets of Skull device driver while we learn device driver programming and finally integrate them to Skull device driver. Let's see how the Skull device driver file operations look like. The Skull device driver which we are going to write will have only few file operations included. For example, the structure looks like this. A structure skull_fops initialized with various function pointers. First parameters will be assigned to this module. llseek function pointer is assigned to skull_llseek. The read function pointer is assigned to skull_read. Similarly, function pointers of write, ioctl, open, release are assigned to respective skull functions. Just to recap, we learned that OpenFile in Linux is associated with its own set of functions. This set of functions are included in a field called f_op, which points to file underscore operations, usually called fops. We have gone through the set of function pointers in fops. We have also seen how these file pointers are used in Skull device driver. Hope you are clear on file operations topic. Coming to our next topic, file structure. This is defined in fs.h Linux header file. Many novice Linux device driver programmers are a bit confused with file and file in caps. File is different from caps file pointer of user space programs. File in caps is used in C library and it's not used in kernel code.